How are the road markings classified? These are mainly classified on its properties, how it is laid. For example, longitudinal markings, which runs all along the road, like lane markings, center line markings, edge markings. They can be classified as traverse markings, which are transversal to the path, travel path, like the stop signs, give way signs placed at the junctions. They can be classified as hazard markings, which tries to warn you on the hazards, like merging traffic ahead, like diverging traffic ahead, where we provide chevron or diagonal marking. Sometimes the diagonal marking also represents no travel restrictions, like you cannot travel on it. It is not the area where which is allowed for the traffic. It can be classified as block markings like zebra crossings or the junction boxes. We'll get into that when we look at the illustration. They can be classified as arrow markings. These are the directional arrows showing the possible traffic flows along the road. These directional markings can also be accompanied with word messages to provide an extra emphasis on the advanced directional signs that we provide. It can also be facility markings like uh, dedicated bus lanes have been marked as bus lane, and dedicated parking areas have been marked with. What are the major design theory or the principles of while preparing a road marking plan? It's mainly on the due considerations that we identify the locations and the requirement of marking provisions on those locations. Like if we have a stretch of a road, we need to consider, we need to identify as different zones. For example, a stretch has to be identified as a road link. Road link is nothing but it is a stretch of the road which is uninterrupted by any major junctions, and there we need to identify which are the normal zones, which are the warning zones, and which are the non-overtaking zones. And then we provide all the markings as per the requirement of the zone. For grade separated and at grade junctions, we need to identify the area of pedestrian and cyclist movement and their crossings as well, so that we can provide controlled, we can provide the crossing markings for the controlled crossings. Traffic flow directions also must be analyzed for every lane travel. Like the inner lane may not have an option to travel to the left, or the outer lane may not have an option to travel to the right. And areas requiring the directional arrows, deflection arrows, bifurcation arrows need to be assessed once the layout of the road is finalized. It will also depend on the junction arrangement, the slip road provisions, or the service road provisions. Object paintings. What are object paintings? There are several objects that might be a hazard for the road users, like the curbs, the inner edge curves or the medians, or the outer edge curves of the carriageway, or maybe the crash barrier, the concrete crash barrier which are placed at the center as a median. This can cause us a hazard. This can be a hazard to the road users. So it can be within the carriageway, it can be adjacent to the carriageway as well. There can be objects like say an underpass structure, the box structure just next to the carriageway, or maybe sometimes the structure piers which are placed adjacent to the road. This needs to be painted in a proper black and white so that the retroreflective illumination gives a proper warning to the road users. So we shall take a look over a few of the typical marking layouts here. If you can see in the first layout, you can see a few chevron marking on the islands. The chevron markings which will act as a hazard marking to channelize the traffic. You can see a few lane markings as a storage lane for the left turning movement of the vehicle from minor road. There are a few edge markings along the road and few directional arrows. In the second layout, which is for the roundabout, we can see a few lane markings along the circulatory carriageway, along the approach roads, and you can see a block marking like zebra crossing. You can also see giveaway lines at the entry of a double giveaway line for the at the entry to the roundabout, and even the warning line at the exit of the roundabout. In the third layout, a difference has been shown on what's the difference between a normal lane marking, warning lane marking, and a non-overtaking. It's been shown for both undivided carriageway and the divided carriageway. If you can observe clearly, a normal lane marking has shorter lengths and longer gaps of the dashed line. When it comes to warning lines, the length is longer and the gaps are shorter. When it comes to a no overtaking, it's continuous, solid line. In the fourth layout, a typical merging and diverging arrangement has been shown. You can also see a ghost island which has been used to channelize the traffic, and a few deflection arrows and lane marking along with the edge marking provisions can also be seen in this. On the fifth layout, we see bus lane markings. These are the facility markings, some hazard markings like road humps. The sixth layout is the process on how we do the identification of normal, warning, and no overtaking zones, which we will see in detail in the coming slide. This is an illustration of how we can develop a road signage plan. A road layout has been finalized first before we start developing a signage plan. And see, for example, it has been assessed that it can take a 40 km per hour speed limit. In order to make it as a legal speed limit, a TRO, which we call it as traffic regulatory order, needs to be obtained by the operating authority by submitting a relevant design documents to them. Moving ahead, there's a sharp right hand curve. The driver needs to be warned that there's a sharp right hand curve. So we have placed a warning sign, which is approximately at a distance of zero point 0.6 to the speed. The speed is 40, so it is placed at a distance of say 24 meters. Then while traveling on this sharp horizontal bend, the driver needs to be warned that there's a prohibition of overtaking on this, which is demarcated using a double solid continuous road marking as well, which we will take it up when we come to the development of road marking plan. For the travelers who are exiting from the sharp turn, they needs to be warned that there is a crossroad junction ahead. So we have placed a sign for crossroad junction ahead. Even this has to be placed at a zero point 0.6 meter, zero point 0.6 to the design speed of the vehicle, at a distance of zero point 0.6 times the design speed of the vehicle, that is 24 meters. Showing the destinations to which the major road is leading to along with the direction, and it can also be seen that the text information is provided in two different languages to aid for the road users with different language backgrounds. Information sign indicating that there is a hospital at a 2 kilometer vicinity from this place. There's a giveaway sign indicating that the priority is provided to the vehicle traveling on the major road and the drivers need to slow down and proceed with the caution. This is how a situation is analyzed for the entire road layout, and we arrive at the road signage plan. Let us now see the illustration on road marking plan development. First of all, in the same manner, we'll have to finalize the road layout. I'm here using the same road layout. This is a normal zone which we had identified, and we provide normal lane markings and the center line marking. We introduce a warning line just before the no overtaking zone. This usually warns the driver that you are approaching a no overtaking zone. And you can see that on the sharp turn, a no overtaking zone has been demarcated using a double solid continuous line. This is the marking for the crossroad, a center line marking, and a double giveaway line indicating that the priority has to be given to the major road travelers. A warning line at the entry of the minor road. Why does this warning line is required? This warning line provides a warning to the road user that they are entering a different configuration of the road. It might be a smaller one, it might be a bigger one, but at least a different configuration. A giveaway triangle is provided to provide an extra emphasis that you need to give way for the priority vehicles. The directional signs, we need to analyze what are the directions of the travel that can be possible, and we need to provide all the directional signs for the road users, like bifurcation arrows. At this junction, either the traveler can go straight or to the left. Maybe a right sign should also be included in this. This is how we'll see on the illustration of the road street lighting plan. Street lighting plan. First of all, we need to finalize on the road layout here as well. It's the same road layout that I'm using here. We'll have to identify the luminance requirement for the street, and they should always or mainly be placed at grade and grade separated junctions, or even at the urban centers where we anticipate more conflicting vehicular movements or pedestrian movements. And this street illumination is measured in terms of luminance, with, whose unit is lux. Usually, luminance level of 100 to 300 lux must be provided at the junctions, depending on how big the junctions are. Output luminosity and the spread of a street lamp is measured for the type of the lighting bulb that has been used in the street lamp, and we usually consider 10 to 20% of the overlap of the spread, and then we arrive at the intervals of the street lighting poles that needs to be placed. Depending on the placement locations and space available for the placement of the lighting poles, we can decide on it has to be placed on the left or on the right or at the center with a dual post street lamps. Sorry. Sometimes the wider roads with the divided carriageways, they're always accompanied with a dual lamppost placed at the median to illuminate the inner carriageways, and outer single post lamps which are used to illuminate the outer lanes of the carriageway. Higher vehicular concentration areas and a large areas which requires illumination like toll plazas needs to be illuminated with high mast lighting, which has a larger spread and huge luminous output capacity. So this is a small case study where I have developed a small project. This is a signalized junction. You can see a lot of mandatory signs, warning signs, and information signs in this junction. So let us see the design, placement, operational ability of the signs provided in this section, in this layout. I'll just zoom into the areas so that we get a clear image on that, clear visibility of what signs have been provided. Let's go for the zone one, the which is the section on the north of the junction. In this section, we can see that there's a provision of controlled zone, which provides information on no stopping at this zone. It has also been mentioned a certain days and certain timings where the no stopping has been imposed. We can also see that there are few warning signs on the layouts, like sharp left hand curve placed sufficiently ahead of the uh, start of the curve to warn the drivers of the upcoming situation that there is a sharp curve. Mandatory signs like U-turn prohibited or the stop sign can also be seen here, and also some information signs like it cannot be an information sign, but it's kind of a warning sign itself that there's a signal ahead and a pedestrian crossing ahead. When you look at the second zone, apart from the signs which are already been spoken about in the first zone, you can also see a directional sign, directional information signs, which provides the direction on which you'll have to travel to reach a particular destination and the distance that you'll have to travel. You can also see a flag post, we call it as, giving an information on a facility, nearby facility like a petrol station. In the third zone, this is a minor road when you compare to the major road of the other. I mean, this junction has a major road and a minor road. The major road is the one with a divided carriageway, with 4-lane carriageway. The other one is the undivided minor road, undivided carriageway, minor road. You can also observe that due to the category of the road or the restriction due to the geometric parameters, how the design speeds are varying and how it has been imposed. It's not always the travel path distance that matters when it comes to the placement of the signs. We'll also need to maintain some lateral clearances. Depending on the size of the signs, larger signs like gantries that are provided mainly at the grade separated junctions can have a huge lateral clearance. So once we assimilate all this information and provide in a layout, and also this has to be thoroughly checked by a road safety auditor that safety is ensured at all times through the signage provisions. Now let us see a case study on the road marking, how a road marking plan will be evolved. I'm using the same example here. Let us get into the details of it. In the zone 1, let's get back to that. Here you can see some lane markings provided appropriate standard lane width requirements of the road, and some directional arrows with message words can also be seen, which puts more emphasis. If you can see here that there are a few directional arrows with word messages, which puts a more emphasis on the directional movements, which has already been conveyed through a advanced directional signs. You can also see a few bus stop markings demarcating the exact area where the buses are mandated to stop. You can see a yellow junction box at this location, at the location of the junction. These are very common type of junction box indicating that the area needs to be kept clear of the traffic all the times, and no stopping of the vehicles over this area is permitted, and this becomes a punishable offense. These kind of junctions are pretty common in UK mainly, and some Scandinavian countries. For this to become a legal legislative ban, a TRO has to be published to get it and to impose all those legal rights to make it as a punishable offense if the vehicle stops over the junction box. So once we assimilate on all the locations where what kind of signs has to be provided, what kind of markings has to be provided on the entire layout, we are going to finalize on the entire marking plan. So we'll use the same layout for the study on lighting plans as well. You can see that the wider road has been provided with a dual post street lamp and accompanied with the single post street lamp placed on the sides of the road, and dual post street lamps are placed at the center. I'm sorry, I've not shown any median there, but it is always placed on the median. So here, what's the difference between the other street layout, in the street lighting plan layout, and this? This is because this is a minor road, has got a smaller width, and requires lesser uh, luminance to illuminate the entire area. So here we can place it in a staggered manner. Staggered placement of the single post street lighting can be provided here, since the area is smaller for the minor road, and the output of the single post has sufficient spread and luminosity that they can be placed in a staggered pattern at higher intervals rather than at a lower intervals, how it's been placed at the junctions and at a busy wider roads. This is how streeting layout has been layout will be finalized. However, we will have to design few more elements like ducting cables, the feeder pillars, which feeds energy, the source of power. Now let us see what are the evolutions in this field. The major evolution in this field is the use of intelligent transport system. This is the new evolution in the field and is becoming popular at a very rapid pace. With the rapid industrialization and increase in traffic at all the urban areas, including some of the busy highways as well, they've all been saturated with the capacity. And urban areas are facing huge developments in terms of industries, in terms of commercialization, in terms of residential areas. So the space available to provide sufficient infrastructure for transportation has been squeezed to a very thin strip when it comes to urban areas and some of the busy highways. So now what's the solution for this? The only solution is using technology to improve the capacity and facilitate smooth traffic operations without actually carrying out any physical works. In this system, which we call it as ITS or Intelligent Transport System, the usual street furniture components are usually converted into intelligent objects through technology. If you can see a complete set of intelligent transport system, it will include variable message signboards, intelligent automatic toll collection systems which will reduce a lot of congestion at the toll plazas. This can be done using RFID technology like the FASTag being used in India. And there can be intelligent axle load measurements to identify and penalize the overloading traffic, which is, yeah, again a punishable offense if a vehicle is overloaded than the allowable permissible limits. How can automatic axle load measurement can be done? This is usually done through weigh in motion ramp sorter system, which we call it as. This is a technology in which the vehicle can travel at a speed of even at a higher speed of 80 km per hour, but still the vehicle axle load can be measured to an accuracy of 90%. There can be license plate readers, the flashing cameras that you see on the highways. Those are the license plate readers. In fact, they can aid to automatic traffic counts and see the volume of the road and see how the service levels have varied over the time. CCTV cameras can also be used as an aid for the routine maintenance of the highways, which will give you a real time videos of the roads, and also it might give you information on the accident data or the weather data, or maybe some kind of a disruption on the pavement. So all these units are usually controlled through one centralized control center, which will be set up by the ITS managers. They usually collect the data from the from these components, and they analyze, and sometimes they'll have to distribute this information as well. For example, now all the static information boards are being replaced by variable message signboards. This can provide you real-time information for the road users, like the weather report, or there may be some accidents which has happened over a stretch of a road, or traffic congestion. This information distribution network can be through a dedicated highway broadcasting radio, which is a very popular means of communicating to the road users in UK and in USA. There can be solar paneled street lights, which can make use of renewable energies, and in turn, this can improve the self-sustainability of street lightings. And these street lightings can also be accommodated with automatic luminosity controller, so that whenever the luminous levels goes below a particular lux level, they get automatically started, which will make it efficient, automatic in operations. What are the career paths and the job opportunities that are available in the market for this? For a transport planner, he'll require a thorough knowledge on the provisions and design of street furniture to improve the traffic conditions. Sometimes, even a small provision of a street furniture, if it is provided intelligently at a location, can improve a traffic situation substantially. For example, if you provide a channelizing hazard marking at a diversion, it makes the flow of the traffic very smooth, and installation of traffic signals can improve the capacity of a junction. It can control the flow of the traffic as well. Now, ITS being the only solution that is available to improve the traffic conditions without actually doing any physical work, and ITS exports requirement has never been more in, rather it be in India or in the international market. With with the expertise in the road science and marking provisions, you can be an expert in subject matter expertise for the science and marking provisions. And also for a highway engineer, apart from the knowledge on the highway geometrics, pavement design, highway design, geological, geotechnical, structural design, it is also very essential that he has a thorough knowledge of signage and marking. Now, looking at the building information management is a new arena on the construction and maintenance industry. It is about optimizing the life cycle cost of the asset built by maintaining the information in a structured manner. In this case, our asset would be road and the structures and the street furnitures accompanied with that. It's also very essential for a BIM manager to have a thorough knowledge of this street furniture, especially on the installation, construction, and maintenance of these features. Furniture being one of the major elements in promoting the road safety, an RSA expert, that is a road safety audit expert, needs to have a very thorough knowledge on the provisions and design of the street furniture. This is all about today's webinar.